Hi, welcome to my talk on modern Spring Boot application development. In this video, I am going to briefly talk about some of the new features introduced in Java 17 and 21, and then I am going to talk about some of the important features introduced in Spring Boot 3.x. First, let me introduce about myself. My name is Siva. I am currently working as a developer advocate at Docker, and I have been blogging about Java and Spring Boot and various other Java related technologies on my blog SivaLabs.in, and also I have a YouTube channel with the same name SivaLabs, and you can find me on Twitter on this handle. This is the agenda for today's session. We are going to briefly talk about some of the new features introduced in Java 17 and later versions, and then we are going to talk about some of the major features that are introduced in Spring Boot 3.x, including Testcontainers Support, JdbcClient, RestClient, declarative HTTP clients, and then we are going to quickly talk about GraalVM native image support. Earlier, Java used to release a major new version for every 2 or 3 years. But in the recent times, JDK team switched to 6 months release cadence, where you are going to get a new Java version for every 6 months. And in each release, there will be some finalized features, and some of them could be in a preview mode, which means the community can try out those features, provide feedback, and then JDK team can iterate on those ideas and then come up with a better implementations. So this will help to bring out more features and in a iterative fashion. And these are some of the major features that I personally like in the recent versions of the Java, like records. So if you ever have to create a class that only meant to use for carrying data from one layer to another, something like that, instead of creating a class and then creating a constructor and then providing getters and equals, hash code, all those implementations, you can simply use records for that. And also text blocks. If you ever had to create a multi-line string using all those concatenation operations, it is not very elegant. So text blocks simplifies that quite a bit. And also you have type inference using var, and virtual threads is a major feature in Java 21. And also there is structured concurrency, pattern matching, and a lot more other features also. In addition to this, there are many improvements under the hood. For example, garbage collection improvements, and then security improvements. There are many other things behind the scenes. So a lot is going on in the Java development these days, and it is very easy to upgrade from one version to another, because only a small set of features are keep released in the newer version. So it is kind of not a big bang release, so it is easy to try out those new features and then gradually upgrading the applications. Spring Boot 3 baselined on Java 17, which means if you want to use Spring Boot 3, you need to use at least Java 17 or any of its newer versions like Java 21. So if you are still using any older version like Java 11, Java 16 or something like that, you need to plan to upgrade to at least Java 17 in order to use Spring Boot 3. Okay, so let us take a look at the first feature that is introduced in Spring Boot 3.1.0, which is Testcontainers Support for testing and local development. So what is Testcontainers? Testcontainers is an open source library for provisioning throwaway on-demand containers for development and testing use cases. What does that mean? Let's say you are building an application and you are talking to a database like Postgres and talking to a message broker like Kafka. Okay, so in order to run your application, you need to have an instance of Postgres and an instance of Kafka running. So what you can do? Either you can install them directly on your computer, or you can run them in Docker containers, and then you can run your application pointing to those containers, right? But it's kind of a two-step process. Instead, with the help of test containers, what you can do, you can configure your application in such a way that when you start your application, it will automatically start a container of Postgres and a container of Kafka, and your application will talk to those containers and starts the application. it would be very convenient, isn't it? So in the same way, you can use Testcontainers API for testing also. Like as again, if your application is talking to Postgres database and Kafka, you can use Testcontainers API and spin up those containers and have your tests talking to those containers. And it is very important for your tests to use the same type of technologies like databases or message brokers for testing as well, instead of using any mocks or in-memory databases. Why? Because your in-memory databases might not support all the features supported by your production database type. Okay, so it is very important to have the tests talking to the same type of databases or message brokers that you are going to use in production. So primarily Testcontainers helps in for testing and development, local development. Okay, and Testcontainers support is not entirely new to Spring Boot. Even in Spring Boot 2.x we can use Testcontainers, and it is a little bit verbose. Like here, if you can take a look at this code snippet, this is nothing but an integration test in Spring Boot, and here we are using @Testcontainers and @container annotations provided by Testcontainers library. And when we run this test, it is automatically going to start a PostgreSQL container, and then using dynamic property source mechanism, we are overriding the Spring data source properties to point to this Postgres container. Okay, then your test will going to talk to the database instance running in the container. So that is how we can use in Spring Boot 2.x. And this setup is simplified in Spring Boot 3.x using a concept called service connection, which means Spring Boot knows how to hook up those properties by using this add service connection annotation. So with this, it will still run a container of Postgres and automatically register them as data source properties. You don't need to explicitly do this. Okay, so this kind of a very simplified for testing. In addition to testing, Spring Boot also supports local development using Testcontainers like this. So here, instead of using the main application, main entry point application, here we can create another application entry point class, and then you can define all your dependencies as beans using @service connection and @bean, and define all the containers that you are going to use for your application. Like here, we are just having one Postgres container. Maybe if your application is also using Kafka, you can define another bean with a Kafka container. And then you can run this application, and it will automatically start all these containers and then configure your application to talk to those containers and starts the application. So it is going to be as simple as, if any new person joins the team, all they need to do is simply clone the repository and just run this class. It will automatically start all the dependent containers and then starts your application. It is very easy to get started with. Okay, instead of having externally configure some scripts or Docker compose and then run them and then finally come here and starts the application. It kind of make it simple, just clone and run the application. So now that we have seen at the high level what kind of a support is added, let's take a look at the example and then see how it works. So here I am at Spring Initializer website where we can create a Spring Boot application, and I chose the starters web, data JPA, PostgreSQL driver and Testcontainers. So when I choose these drivers and if I click on explore, here we can see what kind of a code it is going to generate. So here we have the selected starters, and when we select Testcontainers, it also adds this dependency of Spring Boot Testcontainers. And it is a Testcontainers Jupyter dependency, and then as we have selected PostgreSQL driver, it automatically added this Testcontainers PostgreSQL module as a dependency, test dependency. Okay, cool. Now if you explore code under SRC main Java, there is nothing different. It is the regular Spring Boot application main class. And if you explore under SRC test Java, earlier it used to generate only this bare minimum test that just test for context is loaded or not. But when we selected Testcontainers, now it also generates another class with the test something my application, and it contains all these bean definitions based on what are the services that you are using. Right now we are using only Postgres, so it defined a bean of type PostgreSQL container, and then it is having a main class. So instead of running your application using this under src main Java, during local development you can run this test my application class, which automatically spins up a PostgreSQL container and starts the application. Okay, if you are adding, let's say, Kafka, and click on explore, and if you take a look at the same test my application, here you can see in addition to PostgreSQL, it also added this Kafka container as a bean. Okay, so now if you run the application, it will start PostgreSQL container and Kafka container and register the properties with the application and starts your application. So you can run this class during local development, which will automatically spin up these two containers and configure them. So this simplifies quite a bit of local development setup. Here I have created a sample Spring Boot application using the latest version, and let us take a look at how we can use test containers for testing and for local development. Okay, I have cloned the repository into my IntelliJ IDEA, and here it's a Maven application and it is using the latest version as of this recording this video. Okay, here we have Spring JDBC actuator, web validation, and Flyway for database migrations, and PostgreSQL for database. And for now I have added this H2 database dependency as well, but I'll demonstrate a feature that explains why you should use test containers along with the actual type of database for tests instead of using in-memory databases. Okay, so when you add test containers dependency in the starters, it will add this Spring Boot test containers dependency. Okay, so this is necessary if you want to use test containers based local development setup and all. Okay, fine. Now coming to the application code, we have seen under src main Java we will have main application entry point class, which doesn't have anything related to test containers. Okay, and then there is src test Java, and then there is test application. Again here we have moved the container definitions test configuration into a separate class. So here in this containers config, which is a test configuration, and we have defined our Postgres dependency as a bean and also added this at service connection annotation. Okay, and then in our test application we are using that in order to start the application. This now if you start this class instead of this one, it will automatically start the containers. Okay, first let us see what happens if I run application class under src main Java, and if I start this, it's going to fail saying that oh sorry, because we have added this H2 database dependency, it is using a in-memory database configuration and then starting the application. So now let us reload. I have commented out the H2 dependency, and if I start the application, it will fail and says that you don't have any embedded database or you haven't configured any database properties, so it cannot start the application without the database details. Okay, but if you go to under src test Java, you have this test application, and if you start this application right now, it is going to start a Postgres database instance and then configure the application to use it and starts the application. Here you can see in the logs. Okay, so application is started. It also started a Postgres database locally on a random available port. And if you go to console and check docker ps, you can see there is a Postgres database running here. Okay, and by the way, in order to use test containers, you need to have a container runtime environment available. That could be your local Docker installation. Right now I have my Docker desktop running on my local laptop, or you could point to a remotely installed Docker host, or you can use Testcontainers Club. Okay, so if you stop the application, it will automatically take care of cleaning up the containers. So now those Postgres container is gone. Okay, so if any new person joins the team, it is as simple as you simply clone the repository and just start this application, which takes care of starting all the dependent containers. So it will be a very easy to set up a local development environment. Okay, so this is how we can use test containers for local development. But how about testing? Okay, so here the reason we have extracted the containers configuration into a separate class is we can use the same configuration for running the application locally as we have just seen, and also for tests I have created a abstract integration test class, which is a abstract base class, and I have imported the configuration. Okay, and now if I have another application test, and then which is extending the abstract integration test, and here we are simply checking whether application context can be loaded successfully or not. If I run this, it is going to start a Postgres instance, and then it will check whether the application can be loaded successfully or not, and it turns out we can. Okay, so that is how we can use the same configuration for both local development and for testing as well. Okay, we are going to explore more on other test scenario like API tests and other JDBC repository tests in a minute. The next feature that we are going to take a look at is JdbcClient. So earlier, if you have used Spring Boot and talking to a SQL database using JDBC, you might have used Jdbc template. And JdBC template is still there, but it was a kind of a little older API, and this new JdbcClient provides a similar capabilities, but providing a fluent API. So if you take a look at it in this code snippet here, just like how we inject JdBC template, we can also inject JdbcClient. And then here, if you take a look at this query JdbcClient.sql and provide what is the query that we want to run, and then you can bind the parameters, and then here .query, and we are passing this bookmark class. And what it will internally do is, if the column names and the bookmark property names are same, it is automatically bind those properties into this class. And finally, we don't know whether there is a record with the given ID or not, and here we are trying to return an optional of bookmark. So it is much simpler doing this with JdbcClient than if you take a look at the similar method implemented by JdBC template. You can realize that this is much simpler and elegant code compared to JdBC template usage. And similarly here we can see how we can do a write operation using JdbcClient, and you can bind various parameters and then perform the operation. Okay, so technically still JdBC template can do it, but JdbcClient offers a fluent API and much simpler to use. Let us take a look at in the code and see how it works. So here in our code, if you expand a JdbcClient package, here we can see there is a bookmark repository, and under models package there is a bookmark record which contains ID, title, URL, and created properties. Okay, and in our flyway database migration scripts, we have a table called bookmarks with a similar column names. Okay, now we are using JdbcClient for performing various CRUD operations. So if you take a look at this find all, we are simply querying all the rows from the database table bookmarks, and then there are two ways you can populate the data result set into our list of bookmarks collection. So here first we are querying the database, and then we are using an explicit row mapper, bookmark row mapper, that binds the result set data into a bookmark instance. So for some reason, if you have a different types and you want to do some kind of a calculation or something like that, and you can use an explicit row mapper, or if your column names are similar and automatic translation conversion of these property values into this bookmark property types, you can simply do like this as well. You don't need to write an explicit row mapper. Instead, you can simply specify what type of class or record you want to bind the results into. Okay, so this is much convenient. Yeah, similarly you have find by ID, where you can pass parameters and then use explicit row mapper or automatic binding of this record. And similarly you can use save and update. So I would recommend you to explore this repository and find how all other CRUD operations are implemented. Okay, so this is how simple it is to use JdbcClient. Okay, and one more thing, right now earlier I mentioned you should be using same type of database for using for testing also, right? That you are using for production, you should use the same type of database. Why, you may ask, right? So again, here take a look at this users table. We have a user table, and here we have a user record, and similarly we have a user repository. And here if you take a look at it, we have a save method, and here we are trying to insert a record into users table, and so far here it is normal, but here on conflict do nothing return ID. What does that mean? Let's say if you are trying to add a new record with the same email which is already existing, that is going to throw exception usually, right? But I want to just ignore if there is any conflict while inserting a new record. I just want to ignore instead of throwing the exception. And this is a valid SQL query in Postgres database, which is I am using in production database. So I expect this to run fine while testing also, right? So what happens if I use H2 database for testing? Okay, let us see. Here in pom.xml, I reverted the changes here, and now we have H2 database as well. And under JdbcClient, I have a test. Let's say if I don't. So this is a default at JDBC test. What it will do, we are writing a test for user repository, and this is a simple JDBC test, right? So we can use, these are called slice test annotation. If you are using JDBC, you can use at JDBC test. If you are using Spring Data JPA, you can use Data JPA test, things like that. So here we are using JDBC test. By default, when you use this at JDBC test, it will try to register a data source bean using any in-memory settings. Like in our application, we have H2 database driver, so it is going to register a bean of type H2 data source. Okay. Now, if we try to run this test, we can see in the console logs that it will use H2 for running this test. Okay, let us take a look at it, and it is failing, saying that this query syntax is not right. Okay, here you can see it is using H2 database, JDBC H2 database, and it is failing, saying that this syntax is not valid for H2 database, but it is actually a valid database query for Postgres. So this is one of the use case where it is not able to we are not able to run the test using in-memory databases, but it is actually a valid query in Postgres database. So we should be using same type of database, in our case Postgres, for tests as well. So how do we do that? There are different ways of doing that, but this is the simplest option for writing database driven tests. So here, in addition to this JDBC test, we are also going to pass a couple of properties. First thing is, we are saying Spring test database replace equals to none. So by default, when you add at JDBC test, it is going to try to register a data source of type using any in-memory database. We are saying don't do that. We don't need to register any data source bean. And then we are configuring a special JDBC URL using :tc property here, which tells use test containers and then spin up a database container using this image and automatically register the properties as Spring data source bin. So this will automatically spin up a Postgres container and register with the application. Now if you run this, it is going to start Postgres container and run the test. Here you can see now it is started the application using Postgres instead of H2 and test is successfully run. Okay, because this is a valid query in PostgreSQL. So this is the advantage of using Postgres. You will test with the actual type of database that you will be using in production. Okay, so this is how we can use test containers for testing. And we have seen how we have implemented bookmark repository using JdbcClient, and also we have under API we have bookmark controller, which exposes a REST API endpoints for managing bookmarks. Here we have get all, find by ID, and create, and all these things. And remember I talked about records which are introduced in Java 16, right? So many times in our controllers we would pass some request payload, and also we would return some data, and most likely those are kind of data carriers. There won't be any behavior associated with it. For example, take this scenario of creating a new bookmark. So here for this we expect the request payload contains title and URL only. It doesn't contain ID or created it. Those will be automatically created while implementing the API endpoint. So we have used a record to represent that payload, request payload. And Jackson, which is going to be used by Spring Boot under the hood, capable of unmarshalling the payload into this record structure. So you don't need to create a class and then define these as private properties, setters and getters and all those stuff. You can simply declare this as a record, and you can use this in our controller to bind request payloads. Okay, now we have take the bookmark as a record, and then we perform whatever operation is necessary. Similarly, you can also return the data instead of classes. You can create a record and return it as a response. Okay. And if you notice, we also used multi-line text here. You don't need to do awkward string concatenations. We can simply use multi-line strings if the data spanned across multi-lines. Okay, so that is how Spring Boot 3 is leveraging all the Java 17 newer versions of Java features. Okay, the next new features that we are going to talk about is various types of REST clients. So if you have used Spring Boot for building microservices and you talk to any other external APIs, you might know that you might have used REST template for talking to other services. But there are various other types of REST clients now. One of the REST client is web client, which is based on the WebFlux APIs. So if you are building a WebFlux based non-reactive non-blocking APIs, you might have used web client for talking to other API endpoints. But even for reactive based applications, you can still add WebFlux dependency and then use web client for talking to other APIs. But just for using web client adding entire reactive dependency is kind of a WebFlux dependency is kind of a overkill. So what Spring team did is they provided a REST client, which is very similar, which provides very similar API to web client using a fluent API style, and it is much simpler to use REST client compared to REST template. In addition to REST client, there is also added support for declarative HTTP interfaces. If you have used Fiend, there was a Spring Cloud Fiend project which provides a simple interface-based REST client approach. You can declare what is the base URL, and you can define API endpoints using annotations like get exchange, post exchange, and you can bind the path variables and headers and things like that, and Spring will take care of generating the implementation dynamically. So this is very similar to Fiend, but you don't need to now that this declarative HTTP interface support is added in the core Spring framework itself, you don't need to use Fiend anymore. You can just use these HTTP interfaces. Okay, now let us take a look at how we can use these various types of new REST clients. So here is a JSON placeholder public API, which is a public API with the mock data. So here you can see there are various posts, and you can use users, things like that. For example, here if you make a call to /users API endpoint, you can see a list of user details are returned, and if you want to get one particular user by ID, you can pass the user ID and you will get only that user information. So this is a public API available, and let us see how we can use these various types of REST clients to talk to that API. Okay, so here I have my code, and under REST client, so here is my REST client config class, which is a Spring configuration class, and here I defined a REST client type bean, and here I am injecting the value placeholder API base URL, which I configured in my application properties. Okay, and by taking that base URI, I am creating a bean of type REST client. Okay, this is all I need for creating a REST client bean. Once that bean is there, what we can do, we have a service class and we inject that REST client as a dependency, and we have implemented various methods to get all users data and to get a specific user by ID and to create a new user and various operations. So here this is how it provides a simpler fluent API. We are making a get request, and this is the URI, and we retrieve the response, and we are binding it to type this list of users. Okay, similarly for getting a single user information, this is a get operation, and the URI is this, and we can use the placeholders like this, and we can pass all the values for placeholders, and we are saying we accept JSON type response and then retrieve, and automatically bind that response payload into whatever the class that we want to bind. Here in this case we want to bind it to user. Okay, similarly for post operation, you can specify we want to make a post API call to this URI, and also either you can provide string representation of the payload, or you can pass the object itself, which will under the hood convert into JSON using Jackson library. Okay, so this is how you can use REST client for performing REST operations to invoke any third-party APIs. Similarly, we can use HTTP client. Let us see how we can use HTTP clients. So here we have created an interface, JSON placeholder HTTP client, and we have defined various API endpoints as interface methods, and we have used appropriate at get exchange or post exchange. Remember that there are some common annotations that you use typically in your controllers, like path variable, request body, but this is at get exchange, not get mapping. So remember that, otherwise it is not going to work. So you need to use get exchange, post exchange, or delete exchange annotations like that. So, and once we have created this interface, we can configure in a configuration class a bean of type that interface, and again here we are injecting that value base URI, and we have created a REST client object by taking that base URI, and then we have used HTTP service proxy factory. So this is going to dynamically create an implementation of this interface. Okay, and finally we are going to create a client for this interface. So once we define this bean, we can use it, and then we can call what are the operations we define in this interface. So let us take a look at the test. So under HTTP client there is test. Again here we are injecting this client, and then we are calling client.findAllUser, find user by ID, and it will work. So let us run. Okay, so similarly we have under REST client, we have injected placeholder API client and then calling the methods here. Okay, so basically there are different approaches in order to talk to other API endpoints. So which one to use? If you are building an application using Webflux, using non-blocking reactive APIs, I would recommend to go with web client. If not, I would say either go with REST client or HTTP interface. Technically, whatever you can do with REST client, you can also do with HTTP interface. And these approaches, going forward, I would prefer to use either of these REST client or HTTP interface compared to REST template. Okay, so these are the options available. Next, one of the major feature introduced in Spring Boot 3 is GraalVM native image support. So traditionally when we are building a Java based application, we finally build a jar file, be it a fat jar or var file, and then we need to have a JDK or JRE to run the application, right? So with GraalVM native image support, we can convert this application into a native executable. Instead of a jar file, we can create a native executable and then use that without even having Java installed on your machine. Okay, and why do we need to do that? Because it will create an optimized native executable with which takes comparatively very less memory, and it will be much faster, especially if you are trying to create a serverless workloads or things like that. It is definitely advised to leverage this GraalVM native image support, which consumes very less memory and also provides a sub-second startup time. Okay, and while building Spring Boot based application, if you select native image GraalVM native image support, it will automatically add this plugin. When you are using Maven, it will add this GraalVM native Maven plugin, or if you are using Gradle, it will also add GraalVM plugin here, and it will also add support for building a Docker image. So here, while building a Docker image, you can enable this native profile, and it will, instead of using a JVM based artifact, it will create a native image and then package it as a Docker container, Docker image, right? So you can use this and enable, you can build a Docker image and then you can run it. So here, while generating the application, if you select this GraalVM native image support, okay, and explore, it will automatically add this GraalVM native plugin. Because we have selected Spring Data API, it also added this Hibernate Enhanced Maven plugin. So it will take care of performing required optimizations, and you can use Maven goals to build the Docker image here. Usually it takes quite a bit of time to create the Docker image, and I would encourage you to try these commands and then build image and run the application. So here I have the commands mentioned here. how to run using GraalVM native image mode. You can build a native image, and then you can use Docker Compose to run the application. So here I have a compose file which configures a Postgres database, and then image here, and you can start the application. And you can compare the performances without using GraalVM native profile, which will create a JVM based artifact and then create the Docker image, and you can see how quick or how much memory it is taking, and then you can build the application using GraalVM native mode, and then you can compare the performance. So they should take less time to start, and then less memory to run the application compared to JVM mode. So these are the various features that I find very interesting. In addition to these, there are a lot more other features also, like virtual thread support and project crack. So there are a lot more things that are introduced in Spring Boot 3.x versions, and so far we have seen some of the interesting features. And also I would like to give some references so that you can explore further if you are interested. One of the thing is we have talked about test containers, right? So I would recommend you to take a look at this test containers website. Here you can find test containers is not only for Java, it supports many other popular programming languages like Go, .NET, Python, Node.js, and many other programming languages as well. And it is not specific to Spring framework only. You can use with the plain Java applications. You can use with other frameworks like Micronaut, Quarkus, or other types of applications as well. It is nothing tightly coupled to any specific framework. You can use it in any Java based applications. And also there is a test containers desktop application, which is free application. You can use it for local development purpose. So when you are configuring your dependent containers and everything, those containers will be starting on a random ports. Okay, so when you define this PostgreSQL container and you start your application, the container does not start on 5432 port, which is a typical port for PostgreSQL database. But okay, let us see how. Okay, now I just started this test application, and if I take a look at Docker VS, you can see on my host it is bind to 58632, and inside the port, inside the container, it talks to 5432. So the reason is test containers does not use fixed ports by default, so that it will allocate a random available port, so that it won't give any conflicts when running in the CI server or anywhere else. But how about during testing? What if you want to connect to the database and then check what is the data inserted into so and so table or not, right? So if it is going to a random port, every time when you restart the application, if it binds to a different port, it will be a little bit challenging, right? So for this purpose only, there is a test container desktop application which you can install, and then it will provide many facilities that will help during the local development. So this is test containers desktop application. Here I can see the list of all the containers that are running, and also you can switch to different runtimes. You want to talk to local Docker, or you want to talk to test containers cloud, and also you can see what are all the containers you have configured. You can see the logs, so various things. Okay, if you want to know more about test container desktop features, if you go to testcontainers.com desktop, and there is a link to guide simple local development with the test container desktop. Here you can see various features of test container desktop. Okay, I highly recommend you to go through it. And also another resource that I highly recommend you to go through is these guides. So in this test containers guides, there are a wide number of tests that are covering various use cases, like okay, if you are using a Postgres database, how to do it. If you are using Spring Cloud AWS application, how to test it. If you are using a mock server or wire mock, how to test it. If you are using Kafka, how to test this application. So there are various guides available in test containers guides. I highly encourage you to take a look at them. And one last thing I would like to you to take a look at it is, if you go to Atomic Jar blog, and there is a test containers best practices blog post, which I highly recommend you to take a look at it and then go through it. So there are some best practices that you should follow to utilize test containers in the best possible way. Okay, so I added all these links. I will add all those links in this repository. I will add this repository link in the video description as well, so please check out those links. I hope you enjoyed this session and get to know some of the new features introduced in Spring Boot 3. And I would like you to comment out what are the other features that you would like to explore more. Maybe I will make more videos on those concepts. Thanks for watching. Bye bye.